Hi, Bruno from ATS-Pro. In this installation tutorial, we'll cover site preparation, what to expect when you receive your order, installation, and some best practices. Let's get started with site preparation. At ATS-Pro, we swear by the 5 Ps. Proper preparation prevents poor performance. There's a few things you should keep in mind long before you start your installation. Once your order is placed with ATS-Pro, shop drawings for the project will be drafted. These will detail dimensions and weight of the wall, suggested backing, placement for mounting hardware, and the required location for electrical and data lines. Make sure you share this information with the site design or construction teams to get these requirements included in the pre-build. Your mounting surface should be flat and should be of a construction that can sustain the weight of the wall. At ATS-Pro, we almost always recommend 3/4 inch plywood. Its thickness helps to smooth out any bumpiness in the wall, and it gives your mounting screws or lags plenty of meat to dig into. For power, you have the flexibility with all Taylor LED product lines of using either 120, 208, or 240 volts. But make sure you discuss this with your sales engineer before placing your order, and we'll make sure that you have the proper cabling for your project and that the circuits are properly load balanced on the wall. Your shop drawings will identify the ideal placement of electrical outlets and data lines. It's important that every effort be made to install power and data as close as possible to the location called out on your shop drawings. Good site prep will go a long way to help you ensure a smooth installation. Now let's break down your order and get familiar with the hardware you'll receive. Before you unwrap your pallet, find the packing list, usually on top of the pallet. You'll want this to check what you received against your order, to make sure that nothing was lost in shipping or that anything was damaged. So everything should be fairly organized here and neat. We'll see here that we've got our wall mounts. We have our Novastar processor, your vacuum tool, and these boxes contain our modules, your trim kit, and the last boxes you've got are your frames. We've unpacked our drawings, all of our hardware, and we're ready to start installing. Looking at the drawings, we see that this 4x4 video wall, 4x4 meaning 4 panels wide by 4 panels tall, is 8 feet wide and 4 foot 6 inches tall. In this installation, we're going to be putting the top of the wall at 80 inches. So we've marked our top line at 80 inches, and that will be the top of our screen. Our center line bracket will sit in the center of the screen, and the mounting hole is 75 millimeters down from that top. Put a mark at 75 millimeters. And then at 75 millimeters, that's where we're going to put our laser. Okay, with our laser sitting at our 75 millimeter mark, I'm going to take a level and set it on our center line and make a line across our laser. That'll be the center line of our center bracket. From that point, I'm going to measure over 50 millimeter. And I'll talk more about this line later, but this will be the edge of that center bracket. The WU panel is 2 feet wide. And these 8mm screw holes correspond with the mounting holes on the bracket, which means this panel will sit perfectly on the center of that wall bracket. So placement of the next bracket will be 2 feet over. 2 feet there, 2 feet in this direction. Now, the outside brackets are a different dimension, and that's for the obvious reason that we don't want the bracket overhanging the edge of the screen. These are centered with the mounting holes on the bracket. And if we take a look at a panel, we see that the mounting hole from one side to the far bracket is exactly 570 millimeters across. So that will be the distance from this hole to the next one. 570 millimeters. 570 millimeters. Now, in these positions, we're going to make pilot holes. The reason we're going to make pilot holes is because if we go straight in with a screw, the screw might walk a little bit before it gets in, and you won't have as clean of alignment vertically, potentially, with that bracket. If we do a pilot hole, we can be very exact, and when we hang those brackets, we can let gravity be our friend and have everything sitting perfectly level. For this installation, what we like to use often is a 1" by number 10 spack screw. It has an aggressive thread, but it's a thread that is wide and really holds, and that's also why we like the 3/4" plywood. That screw will be engaged all the way through the mounting surface. All right, with the basic placement of all of our brackets set, now we're going to level them out. We're going to find that 50 millimeter mark that we made when we first marked our center hole. That's for the edge of this bracket. So if we set the edge of this bracket there and tighten this down, that should be exactly where we need it to be. Put a level on it. It's pretty good right there. We're going to shoot another screw in there. For spacing on the next, the way we're going to do that is we're going to use our alignment tool. The alignment tool that comes with your order basically fits in the 2 holes at the top of the bracket, there, and here. Now our spacement's perfect. We can go ahead and tighten this in. And we'll do the same on the bottom. And we can put a screw in there. On the outside brackets, as you can see, there's only 1 hole. So for those, we'll use the 2 pins and holes on the medial bracket, and on the edge, we'll use that inside one. And we're going to do that at the top. That's good. Lock it in. I'm going to double check the top. Perfect. Check these. Perfect. Good. So we're going to continue with our lower brackets. We're going to switch alignment tools. We're going to use the vertical alignment tool, making sure that our brackets are the right way, that the narrow part of the hole is down. We're going to insert that just like that. And that's properly spaced, and it's pretty close to properly aligned too. So I'm going to place this on the bottom. I'm going to put it in tight. And then removing the spacing tool, I'm going to put this up along the side and just make sure that they're in line with each other before inserting the top screw. That's perfect. That's perfect. And that's good. It's perfect. These are the 8mm or M8 lifting bolts that are used to hang the panel on the wall brackets. These just screw in. They don't have to be super tight, but they do need to be seated all the way. And it's actually something that you should watch for. It's not uncommon for sometimes someone to not be paying attention, feel it resist, and think they're down all the way, but in fact it's standing off 1/8 or 1/4 of an inch, and it will create problems for you when you're trying to fix seams on the walls. So make sure you are conscious about the fact that they are screwed all the way down. And if it's giving you some resistance and you need to get it down a little bit more, it's got a slot for a slotted screwdriver. So that's what it looks like after it's installed, and you see that they simply go on and hang just like that. It's that simple. We won't start in the middle though. We'll start at the bottom. We'll start at the bottom row on the right side. Before I continue putting on panels, what I want to do is I want to go back to the first two I've set and tighten the interconnecting bolt on them. To do this, you'll need a 10 mil wrench. We like to use ratcheting box wrenches, which are really nice for doing this. I'm going to tighten these not much more than hand tight. So we want the panels to make contact without over cranking these together. The other thing is we want to check the top for flushness. They should be perfectly flush with each other. So we've got the first row of panels installed, and I'm just going to go through and double check to make sure that they're nice and flush with each other and good. Like I said, I didn't put a lot of force on those, maybe just a quarter to a half a turn past contact. With the first row in place, this is when we'd want to connect our power and our data. So for this installation, we're going to use two 3-meter Y split cables for our power. It's basically 3 meters long, but then it will feed 2 panels. That'll give us the ability, typically, if your outlet was at the top as it should be, you'd come down and feed your panels from here. But in this instance, we're going to go here. There's a plastic port on the back of the panel, which we're going to remove. The bottom power connector, we'll disconnect, and we'll get that out of the way. And we'll feed our power cables down. This one's going to come through the panel. This one will come here, like so. And we'll pull the slack up and keep that behind the screen. We would also be bringing our data into this as well, so we'll disconnect the data in. What is often typical is to put a data port on the wall. What we prefer to do is we prefer to bring the wire out of the wall, the cable, your Cat5 cable, out of the wall with some length and install an RJ45 connector so that you can go directly to the panel. Now, the benefit of that is if you have data issues in the future, you can simply cut that connector off and install a new one, and you're good to go. Now, what I'm going to do before I tighten my horizontal screws, I'm going to tighten the vertical ones. So they come up from below. Come in closer, Mike, I want to show this. This panel was a little recessed compared to this one. And so I stuck my wrench through here and I just kind of gave it a little tug, which made contact on the back side of this hole and pulled this forward, and now it's perfect. There's a significant gap between these panels. It's not a big deal because as we tighten these, it'll pull it right in. And contact. The first step is just interconnecting with the built-in interconnects. It's super easy and a wonderful feature of the Taylor panels, the Taylor W and a few others. It has this swing arm that basically raises a connector to interconnect power and data. So an important thing to discuss with the data ports on the W hub card. You'll see you have a data in main and a data out main. They're bidirectional. There is no in and out. They're printed that way on the cards, but you can use either one. That's why in our interconnects, we're able to go out of the data out main to the data out main of its neighbor. The data out backup and data in backup, these are for redundant receiver cards, which typically aren't used, and they're used in, mission critical installations like military and things like that, where super redundancy is important. What we're going to do is this top panel, we're going to disconnect the data main out, that gets disconnected, and the data main out in its neighboring panel. So we'll go like so. So we've got the data coming up, goes over, comes down to the third column, goes up, and it'll go across these two panels. Before we put the trim in, there's a few things that we need to do. We need to remove these horizontal and vertical junctioning bolts, and we have to remove the guidance pins at the top of the screen. So to remove these bolts or screws, we just need a flathead screwdriver. We take that screw back and the screw slides right out. To remove the guidance, the alignment pins at the top of the panel, I typically use a 2.5 mil Allen wrench. So we're going to start installing our trim on the top. You'll notice that the holes down the length of this trim they favor one side over the other. This side, the holes are towards the front of the trim. These holes line up with the holes on the panels where the interconnecting screws were. On the bottom, it's exactly the same, just upside down. Up the sides, we have our right and our left side trim. You can see the difference between the left and the right side trim. There's these indentations here, which correspond to these alignment pegs that are on the side of the panel. It fits into those. So we'll put these on. Okay, so our trim's installed and we're ready to install modules. So let's unbox our modules. Each box contains 4 modules, or enough modules for one WU panel. The modules don't use ribbon cables or power cables, which makes installing them very quick. I'll show you. Starting in the center, I line up the bottom of the module with the bottom of the panel, and it's that quick. It's that easy. With one person holding the modules and handing them to the installer, you can move very, very fast. Now this is the 2.5 module. On something like something of a tighter pixel pitch, you might want to go a little slower, just because they are more delicate. But this 2.5, which is very popular for us, can go together very quickly. While it's not important on this wall, on larger walls it's important to start in the center and populate your modules out to the edges. That'll help you deal with any tightness that you might have in the modules as you populate. Your order comes with a vacuum tool, which you use to remove modules. To use it, it's pretty simple. Just line it up with the module, squeeze the trigger, and it comes off like that. Now, to turn the vacuum off, there is a little plastic tab on many of them that will engage the top of the trigger to keep it engaged and on. So just push that up to turn it off. I'll show you. Just like that. So we finished building the wall, wiring, installing the trim and the modules. Now it's time to connect to the LED processor and do a little configuration. The processor we're using today is the MX30SF. The MX30SF is part of Novastar's coax line of processors and is exclusive to ATS-Pro. Let's connect and configure. You can see that we have 10 ports on the back of the MX30SF. We're going to use one in this case because of the size of the wall and the number of pixels that we are driving. And we'll go straight into port 1. We have our network connection connected and we're connected to the laptop. So to use the VMP software, you have to be running one of Novastar's MX series processors or the KU20. So that would be, the full line would be the KU20, the MX20, the MX30SF, the MX40 Pro, along with the ARM receiver card must be installed in your panels. Without those, you can't use the VMP software. So the first thing that we're going to do is set our canvas size. Our canvas size is the size of the display that we've built, 960 by 540. Next, we'll go over to layout. So what I'm going to do is I'm going to click on port 1. You can see port 1 is active. It's the one that we're plugged into. So if I click on that, and I'll take my first panel, drop it in the corner. This is our panel 1. And if I hold the click and drag this out, I can actually populate this whole thing out. Now it has natively used this wiring configuration for this layout, but I could change that. If I click on Swift Layout enables us to quickly take all of our ports and intelligently fill it in a uniform way. If I click in this position, you'll see that if I hold and drag, I can populate the wall automatically. And then depending on how it's wired, I can change the wiring configuration. In this case, we wired it the same as the default in the Swift layout. So that's done. I hit done, and you can see we've already finished mapping the wall, which if you're familiar with Novastar LCT, this is an incredible, incredible advancement. Let's switch the source over to HDMI 1. We can drag that out, place it on top of our other source, and if I come over here to the fit screen, and it fits right in place. And that is our single source mapped to the wall. There's a lot more here to unpack with layout, correction of bright lines and dark lines, color processing. There's 14-bit color correction, different screen settings, color temperature, brightness gamma, monitoring features, and other presets that you can set up. Obviously, there's more to unpack here, especially with the VMP software, so look for our other videos for that. But if you have any other questions or need assistance, refer to the documentation that came with your order or on that USB drive. You can also reach out to us at support@ats-pro.com or call us at 800-755-3235 option 2 to reach our support team. We'll see you next time.